Hello, everyone. We are back here with another Fireside Chat. This is our Fireside Chat 22. And before we even start, I just wanted to remind you, if you're really enjoying those chats, like please subscribe, leave a comment. And if you're new to this channel, or at least to the Fireside Chat, uh, basically like the Fireside Chat are topics that we normally have some informal conversations about, and we decide to record them. So like we normally like talk that in a very informal way without a lot of preparation. And today we were talking about coupling and cohesion. And normally we talked about coupling and cohesion at the software level, right? So how we align our components and classes and systems and services. But we also realize that coupling and cohesion can be more universal concepts, if you like, that can be applied beyond the software. And this is the conversation that we were having, and they said, "Wow, why you know what? Why don't we just hit the rec button and have a fireside chat about it?" So, but before we start, so why don't we, for people listening, maybe even non developers listening, what we even mean by coupling and cohesion? If we start with some definitions, probably would help. Yeah. Who would like to do that?
Mash.
There we go. Thank you. Thank you.
Nash is good at defining things.
At defining stuff, and then we can correct him.
Yeah.
Yeah, thank you both. I'll give it a go, and then you'll say, no, I'm not good at defining stuff. But anyway, so I'll take a very and I'll be simplifying it because we are going to go into details, and I'll take the perspective of change because coupling and cohesion can be defined in different ways. But let's take the perspective of making change happen, right? And the way that I would say is that cohesion actually describes the things that change together are close together, so they can be chained together easily. And the coupling is that things that don't need to change together are suitably apart, so changing one is not impacting the other. So to me, this is the basic definition of coupling and cohesion. Cohesion, things that change together are together, and coupling, things that don't need to change together are not impacting each other when one is changed.
But they are related. So that's
Yeah,
the tricky bits, right? So they need to communicate, right?
that's right.
So yeah, again, I have a very similar view. Like it's more like everything that is strongly related, they should remain together. But that's exactly like the change in perspective is very interesting. When we are modeling systems or designing systems, and we need to define our from low levels, like for example, from class and method levels, all the way to systems, right, to services. It's all about how much behavior we're going to keep it together and how much behavior is going to be isolated. So how this group of behavior that is strongly related to each other is going to be available to other parts of your system, and how do they talk to each other, right? So because you want to keep the, as you said, Mesh, like behavior belongs together, so they normally change together, isolated from other pieces of behavior that also have their degree of cohesion, let's say, but they also need to interact. And the interaction is the coupling, right? So is the degree of coupling that you have. So all those different cohesive pieces, how do they interact among themselves? How many interactions do they have? And by interactions, we also talk about dependencies, right? So they depend on each other as they have those interactions. And the type of dependencies and the number of dependencies also will dictate the degree of coupling that they have and impact on the change as well.
Yeah.
Yeah.
In fact, this brings to my mind is one of the diagrams, in fact, from Christopher Alexander that talks about, and it's in on his notes on synthesis of design. And basically, what he talks about is, I think it's the right title. It's notes on something anyway. But he actually talks about, he takes nodes, like one node depends on another node, right? And let's say you introduce another one, and that needs to depend on these two, right? So, and fourth one And each new node that you introduce has this, I think it's, if I get the math right, it's an n square thing, right? So as you increase the number of nodes, the complexity of all of them connecting with all of the others increases exponentially. But that's where this idea of modularity comes in. Because then what you could do is, if you took those nodes and grouped them, let's say in 2 groups, and only allowed the one group to connect with each other in that, and the other group to just connect with their own groups, you obviously just reduce the dependencies massively, the connections massively. But then how do those two connect with each other? And you define a module with a single connection, the protocol for them to talk to each other. And so you have simplified the problem, the complexity of that system in its networks, in its communications, right? So communication, reducing that communication overhead by creating cohesive units that then speak to each other at a module at a higher level is the trick, basically. And there you got the cohesion, as in they need to talk to each other a lot, so you can't divide them too much. But the things that don't need to talk to each other too much, you are creating a higher level of coupling to reduce the coupling at the lower levels, right? So this is that's how he describes the basically design in the problem space, how you simplify the communication in the problem space that you can then take towards the design space. But again, it's that trick of simplifying connections.
Yeah. No, and the thing is, I would have kind of defined it a bit differently, more as a measurement of how much things, let's say, are similar to each other, either in function or there's some sort of commonality to them, and how much things depend on each other, right? Which is a similar idea to what you expressed, no? Like things that change together and so on. That's kind of like the application. Like what happens is, if I have to change something, then that spreads through those connections or those dependencies and so on. And one thing that people tend to forget, or let's say approach when they're talking about software and they're talking about cohesion, is like they use the module, or they try to say use whatever boundaries the language has to kind of be the unit for those things. If it's a class, if it's a right, but there are other things that create that cohesion as well, right? And you may think of them as at the functional level, right? Like what function they perform. So for me, that will be kind of that another aspect to that, not just the structure of where they are in the code, no, so to speak. And I feel again there's lots of ways, no, to define the different types of cohesion and the different types of coupling. We probably want to go more into as well and analyze how these things look from a organizational point of view. And we already did an episode on the reverse Conway law and all of that stuff, right? And this has a lot to do with that, I would say. But let's do a pass through all of those, like the different types of coupling, the different types of cohesion, and then maybe try to find some of the similarities.
I think before we go into that, maybe Sandro, you may want to talk about the nature, the balance, the spectrum, those kind of things. Kind of more talking about the nature of coupling and cohesion, actually.
Yeah. So those concepts are often like reasonably simple to explain, but they are extremely difficult to get the balance right. Right. So, for example, we mentioned things that change together normally stay together. Like but how many of those things? Imagine like let's keep on the software side because it's easier for me to give examples, right? Then we can move to the organizational side. But like you take a monolith, right? There are things that are related to each other, and it's very easy to say. For example, any logic related to payments, yeah, you should put them together. Any logic related to a catalog, maybe you should put together. But they are the same system, and there are user journeys, as you were saying, Jose, that's going to go across some of those boundaries, right? Let's say. So there is also an art of putting things together. How much do you put together? Let me give you an even more concrete example. I mentioned payment and catalogs. Yeah. So those, like in domain-driven design, we call them normally bounded context, let's say. So those are not language constructs. They are domain-specific aggregations, let's say, right? So you have things that are, the boundaries are dictated by your programming language, like methods and classes, right? That allows you to create those boundaries. Then you have a system boundary as well. So everything that is within those deployables. In between, you might have some namespaces and packages, but it's already getting complicated because like how many classes or functions do you put in a single namespace? How many namespaces do you have? How do you have sub namespaces? Even the payment example I gave, let's say all the payment logic goes there. But like within the payment logic, how much logic do you put? Because the payment processor, let's say there is an area of your system that deals with payment. It deals with potentially credit cards, Apple Pay, Google Pay, PayPal. So how do you organize those things? Then it has fraud detection, which is a huge system on its own. It needs to store confidential data, it needs to be PCI compliant. So even within a thing, so then we say like, what does it mean cohesion in that? So then you will start understanding that cohesion and coupling, but I'll stay in cohesion for now, applies at multiple levels of abstraction, right? So if you are at the class level, you can say like this class will be responsible for this kind of behavior, this class will be responsible for this kind of behavior, but those classes together, they also are in a higher level of abstraction, they represent a component, right? And this component now belongs to a bounded context, that is the fraud detection. But fraud detection is a sub-context of the payment system. So you see what I'm saying? And then you say like, how do I deploy that? So then because why this is important? Because you have levels of cohesion within those definitions, but you also have degrees of coupling within the units themselves, within the payments area. How does the fraud detection and the different payment methods related to each other? That's the coupling within a cohesive unit. And then you have the coupling of the payment unit with the then other bounded contexts, for example, like the catalog and the client or customer area and stuff. So as you can see, so those things, they will vary from levels of abstraction, and the communications between them also change.
This was my point before, because precisely, you're kind of using those boundaries, the class level, the context, and so on.
The
right?
class and system is easy because they are hard levels. All the other ones, we make them up, right?
Yeah, but you can have the boundary and you can have, the class and not really have cohesion. You know what I mean? Like this is what I'm trying to say. Like the concept is not only at the, structural level. It goes beyond that. No, it's about the communication. It's about the sequence. That all those things also create cohesion. No, when you mentioned there's a journey and so on, those things for me also create that cohesion, right? And the thing that people ignore sometimes is that they tend to focus on the structural aspect of it and think that because they have a separation structurally, they have a separation, or they have a they either have cohesion or they have loose coupling on the things that they do, because they're introducing a separation, and that's how you get the distributed monolith, right?
Yeah, I think it helps in this case to go back to the the original definition that I gave, which is that if you want to say that two parts are not coupled together, then you need to do a mental exercise of saying, well, if I change this, would I need to change that as well? Right. So it's kind of going back up that level, because you're right. People can create two, for example, two services, microservices or whatever, and often you find that both of those microservices are relying on the same database table. Well, if you change that table structure, you may need to change both of them. So you are impacting. So you are introducing coupling, but you think they're two microservices. They are coupled. They're not loosely coupled. That's the point of microservices, to be loosely coupled, right? And so yes, you do have you do have to think about beyond the concepts. One thing, Sandro, you were talking about is this cohesion and coupling exists at all the different levels of software, and of course all the way going into organization, and we'll talk about that in a bit. But even talking about the different levels of abstraction, I think there is actually the concept has a name. It's kind of called stratified design, where it actually, all that it means is that introducing abstractions at each level, you creating a domain language that you then use to solve problems at a higher level at the next level, right? That's all it means. You create what you are really doing is creating a hierarchy of domain languages, a very low level domain language at the bottom, a very high level domain language at the top that is actually combining systems, right? So and in all those cases, when you talk about the idea of coupling and cohesion, you're talking about a particular level, one concept, one part, one module. Highly cohesive actually means that it's highly coupled inside. That's why it's highly cohesive. But at the boundaries, when you talk about the connections, it's low coupled in the sense that it actually has low cohesion at that level, right? So that then this is what that kind of balance side of things as well is that like a lot of times one of my interview questions is around, like, sometimes people start discussing, like, single responsibility principle, and I say to them, well, okay, it's very easy to achieve single responsibility. Just really divide it down to the minutia. Then everything has single responsibility. But how do you know you've gone too far? Right? And actually, this whole idea of coupling and cohesion tells you when you have actually gone too far. Because within the same level, because you've gone into dividing the problem more and more, you're making it coupled. You've got bits that should be together are no longer together. Even if, like, we talk about LCOM4 and so on, even if you achieve that, you might have high cohesion, but actually you might have just got high coupling as well, because although you had you've really achieved high cohesion in terms of LCOM, and you can find that out in, like, SonarQube, and Sonar has that kind of metric. You can find out what the definition is. You can actually have introduced, you've optimized at the local level, but at a higher level, what you've done is you've created a higher level of coupling. So there is a balance to be achieved. You always have to think about just enough level of cohesion to give you the best or loosest level of coupling at that level. And this is something that you have to kind of keep in mind all the time. Yeah. And that's why this kind of sense actually allows you to apply these lower level principles, like solid principle, for example, in a better way, and not actually shoot yourself in the foot with them.
Yeah, because, like, for example, you gave a very good example that when we try to really optimize for cohesion, right? So it's like, I want to make everything highly cohesive to the latest degree. A side effect of that is to have far more moving parts.
Yeah.
Right? Because you keep further dividing things.
Mm-hmm.
And although the smaller parts become highly cohesive because they becomes very, very tiny and very focused, you now have far more parts to deal with, which means that you need to you introduce complexity on the coupling because now you need to manage all those small parts. You need to make them all, you need to orchestrate all those parts, right? And then you can go all the way to the other end. It's like I have just one part, so that there's no orchestration, but then the internals of that part is a bit messy.
It's an N square kind of communication problem that I mentioned.
Exactly, but then you have like one part, but that part internally is not very cohesive. So, but you don't have a problem with coupling. And I have you mentioned single responsibility principle. I actually had a very a real story. Like when I joined UBS, like the investment bank that you used to work for. When I joined that project, I remember going to pair with this guy, and we were working on a class with about 3,000 lines, 3,200 lines. I think that class had, and clearly to me, that was violating the single responsibility principle that we talk about in Solid, right? And I, in my naivety, I went to this guy and said, hey, maybe this class is a little bit on the big side, right? So maybe I think that this class is violating. Then I wanted to use the nice terms. No, this is violating the single responsibility principle from Solid. And then the guy said, what do you mean? I said, well, this class has more than one responsibility. He said, no, it doesn't. It just has one responsibility. And I said, like, what do you mean? It has 3,200 lines. I said, no, it just has one responsibility. And then I realized the name of the bloody class. The class was called, the class was called like trade service or whatever, but had just one method called process trade.
Yeah.
It took just a big XML. Exactly. It received a huge...
to contain all the code that I'm
writing. Exactly. It received a huge... big XML that did tons of shit inside and would spit out another XML in a queue, and it was processing the trade. So from that perspective, it had one responsibility. And the point that I'm trying to make with that is that you can also, as you play with this concept, it depends on how you generalize those concepts. So this is why I always say that like the single responsibility principle is a bastardized version of cohesion. Right? Mm-hmm. So because you have two aspects for single responsibility principle. One is the external aspect that says like, does it do what it says? And in this case, for this 3,200 line class, it did. If you just look at from that perspective, what is the name of this class? What does it do? Yeah, process a trade, bang, single responsibility principle. If you look at the internal side or the inside, it goes back to what you were saying, Mash, is how many reasons do I have to change this class? And then we could decompose in more than 15. Oh, we need to parse this XML. Each area of the XML is a different thing. We need to enrich this data. We need to send this. We need to log these or to be compliant with that and so on, blah, blah, blah. Who is step in, who is step out of the trade and which kind of trade and so on. So then we could list all the different reasons that we had to change that. And that's when we start saying, now we had a better conversation about cohesion of all the different pieces that could change. But then as we were splitting those things, the overarching module remained the same. It was still the trade processor, but instead of being everything in like a single class, we have multiple subcomponents. So again, the trade processor remained a cohesive unit compared to the rest of the units at the same level of abstraction in the system. But internally, we decoupled that into submodules so that internally there were more modules. We introduced more problems in the coupling, but we made the cohesion. We fixed the cohesion.
Well, this is exactly what I was mentioning when I was mentioning stratified design. It's about different levels of abstraction that actually combined together, create a domain-specific language, a DSL. Mm-hmm. And it is the way to reason about them. And at that level, you can talk about coupling and cohesion but at the next level, it's a different level to kind of talk about.
You need to do it again, right? We need to talk about coupling cohesion, but now in either a lower or an upper level, right?
And this is why I call coupling and cohesion system thinking concepts, and they actually allow you to think at all these different levels and reason about your system. Because as you just mentioned, applying things like single responsibility principle and just going by its definition, but not thinking about systems, either you optimize at one end of the spectrum where you just have a big trade processor, or the other end of the spectrum where you have thousands of little things that are kind of working with each other, and very lots of different levels of this stratified design, as I talked about as well. But you haven't really stopped. You've just kept going down that rabbit hole until you've created something extremely complex. And this kind of thing kind of goes to the microservices stuff, right? People always ask, like, how small does a microservice need to be? Well, as small as you can make it, or as big as you can make it, so that you have adhere to these two concepts or system level concepts of coupling and cohesion, because you are trying to achieve low coupling and high cohesion. You're trying to change one part and not have to change other parts. And the parts that need to change together from a problem side of the problem domain, when you come into the solution domain, they are sitting together, so they are convenient to change together. And so that kind of question goes away. Then how big or how small a microservice needs to be? It needs to be as big or as small as trying to achieve this low coupling and high cohesion at the different levels, at all the different levels, right?
One thing related to that, which is, I think, was not entirely clear, but you sort of mentioned it, right? Is the relationship when trying to simplify. Now, to some extent, what you're doing is you're getting things together that are going to be changing together. You cut, and then you have the simplification, so to speak, that allows you to handle that communication complexity. No, the n square problem that you were mentioning.
By the way, sorry, it's called notes on the synthesis of form. If you want to, it's not notes on the synthesis of design. Just so if people are trying to write down which book to go to.
Okay. And in reality, another thing that gets missed is that you are doing a trade-off there, right? And this is, for instance, to your example of microservices. No, every time that you decide to split, you're introducing. Yes, you are trying to keep things together, and supposedly it's simplifying, but it's also adding complexity at a different level. In this case, if you're using microservices, then people tend to, add containerization and Kubernetes and all these things, and then suddenly you have all of this stuff that you need in order to get your things done, that is handling the complexity introduced by splitting, right? And that trade-off, if you're not aware of it, you end up with the super bulky system that requires lots of things just to it used to be an app, right? Like, it was all here, like I would deploy everything and that's it. I didn't need all of this crap around it, right? And that is something that is missed as well. So it's not just about split and then it simplifies. If you're not doing it properly, if you're not aware of the trade-offs that you're introducing in your architecture and in how you're designing the system, it will you will still shoot yourself in the foot. No?
Yeah, like this is where the whole idea of inherent and accidental complexity comes in as well. There is inherent complexity in your problem domain. You will not get rid of that. Doesn't matter how low you go in terms of microservices and also. All you're gonna do is move that complexity. If you really, if you really go down to like really small services, you move that complexity that exists, that is inherent, into a place where you are ill-equipped to manage it, right? So like, and you need to kind of that complexity remains, and arguably that is easier to manage when things are together and they're just calling each other and there's no network and everything else. But if if that is inherent complexity and you've just moved it up into the communication level where you now have accidental complexities of network failures and all sorts of other things that could get in your way, you've just made your problem much worse, not better.
Yeah. So guys, can you hear me well? Because you were frozen for me for a bit. Yeah. Oh, good.
Yeah,
Okay.
yeah, I can hear you. Yeah.
Mhm.
Cool. So, I've been thinking about those things. Well, in the past, I was thinking about those things. I was creating some guidelines to define, to calibrate this. I end up creating a thing I called back then like the balanced abstraction principle, right? That the BAP, and I was thinking that was something that was missing to the solid. And I'll tell you, it was a shame that when I actually wrote about it, I wrote at a very low level. But just hear me out here. So what I was saying.
Oh, tell me more about the BAP.
Exactly. Yeah.
Sorry.
So
Go for it. Go for it.
So the balanced abstraction principles. For example, how do you calibrate how much behavior you put in a place and how much behavior you delegate? So basically, what you are to define is like what is the boundaries of your cohesion, and depending on how you calibrate the boundaries of the cohesive module, it will implicate how many other modules you will have as well, because you will be further dividing or further accumulating things in the same module, right? So, and the way that I was thinking about it, imagine that each module at a specific level of abstraction has siblings, yeah? And those siblings, they need to be at the same level of abstraction. So the example that I was giving about bounded contexts or functional areas, for example, if I have a module called product, the other module is called client, and the other module is called payments. So product, client, and payments, when you look at their names, they seem to have to be at the same level of abstraction. So if I wanted to break them as components or even services, they are at the right level, assuming that they talk to each other. But let's say that instead of having, I had, I don't know, product, client, American Express, PayPal, and fraud detection. So the PayPal, American Express, and fraud detection, they are not at the same level of abstraction as product and customer or something like that. So, for example, that would be trying to put siblings that are at the wrong level of abstraction. So, for example, wrapping the American Express, PayPal, and fraud detection into a higher level concept like payments, and then make payments as siblings as the other ones. This was the way that I was thinking about calibrating the different levels. And that's the balanced abstraction principle. That's what I was trying to say about always trying to balance the level of abstraction of the siblings. This is one of the guidelines, which I really, probably one day I will write more about, because I wrote at the low level detail and I didn't escalate that all the way. And the other one was concepts of coupling as well. And there are two types of coupling that also help us to calibrate this balance. One is called the fun-in. Yeah, so the fun-in is like you have how many modules depend on a single module. Yeah, so multiple modules depend on a single module. If that's back to the example that we gave, Mesh, of the database table, right? So if this single module changes, it causes a ripple effect upwards to the method, the modules that depend on that method. So it's not a problem as long as this module is very stable. It's a very small and stable module. But if it's a business module in constant evolution, you want to avoid a fun-in. The other one is the fun-out. It's like one module depending on multiple modules. And module I'm using a more generic way. Could be classes, could be systems, could be components, right? So if one module is talking to too many, you know that you also have the wrong level of abstraction. But because what you normally have in there is like one module that is coordinating the flow of modules that are in a lower level of abstraction. Because you are one module talking to, I don't know, 6, 10 modules. So what you are missing in between the single module coordinating the flow of other 10 modules, you are missing some modules in between that would take care of part of that communication. So I mean, that would hide the details. And those are the some of the guidelines.
They actually follow the same kind of things. By the way, in terms of the abstractions at the same level is addressed in stratified design as well. So that it talks about abstractions at different levels, because a language, it's actually a patterns language. That's how it describes it. A pattern a set of patterns that combine together create a language, right? And they need to be at their own level, right? So actually stratified design talks about exactly those kind of things. It talks about different levels and how you need to maintain the patterns at that level, right? And the other thing I think Kent Beck also kind of mentioned, maybe there is one thing called composed method, which is, he talks about it at a lower level, but he's
It's
also talked about it
yeah.
applying at different levels.
Yeah.
The other thing that you talked about, the fan in and fan out, it actually is very, or has a kind of very close link, at least if not identical, to this idea of when you are creating different, when you're creating a module, like when you have one thing that has lots and lots of dependencies, the n squared problem, as I said. And when you create two, when you split it in the middle, you take it one exponential level down, right? And as you said, if you take it to the next level, you take it again to the next exponential level down. If you think something is with n squared, the thing is increasing exponentially. Every time you remove a level and to create modules and to kind of create a protocol between those modules, you're taking that exponential complexity down each level, which actually at the highest level gives you a lot of advantage, almost, and so on and so on. You get diminishing returns as you go further down into the smaller and smaller modules, right? So, and you get higher returns further up. And again, is actually the same concept of fan in and fan out described in a different way, but it's fascinating. I haven't thought about that before.
Yeah, and the interesting thing about that, so that we can move to the other topics that we wanted to cover. But for example, when we are discussing about that, the fan ins and fan outs and stuff, what we are always really defining here is the different levels of abstraction are communication patterns, right? Is how those things are communicating to each other. So if we extrapolate those concepts to teams in a department.
Good segue. Good
right?
segue.
Right, so
Like
or the departments in a company, but this is an interesting thing, right? So how those communications, so how those groups are communicating. So when we are creating teams within a department, create departments within a company, and even like different areas of a product, and how those different departments support the business. What is the relationship between those different business units, for example, again, maybe at the low level, the team, all the way to high level departments, when they talk to each other, what is that kind of conversation? Who depends on whom? Who is orchestrating the communication across those different teams? What does it mean to be cohesive? So again, those same principles could be applicable to a much wider concept. What do you guys think?
I agree, because the beauty about it is that these are, as Mash said, they're system thinking concepts, right? And our organization is a system as well. So you can apply these things to whatever you decide to call components, or elements of your system, right? Whether you're doing at the person level or department or team or whatever level of abstraction that you want to do your grouping at. So I think it's very, very relevant, and you see it often, right? Like teams that have dependency on the same data, or they're passing stuff around that they need in order to work, and this is why certain certain methodologies and this kind of thing that try to optimize for the delivery of value. No, they kind of try to get that cohesion, no, of everything that I need in order to get the value out the door, right? If you look at it, like, let's try to remove the dependencies, because dependencies will inherently be bad for this, right? Like, they will create blockers. So how do we do that? Let's try to put everything that we need together, right? And if you look at concepts like waste and so on, they also kind of try to minimize that, or give you some sort of indication on when you have uh, uh, the wrong level of abstraction for what you're trying to accomplish, right? At least that's the way that I feel like it's similar. What do you think?
Yeah, I think, and this is where I think you mentioned Conway's law earlier as well, right? Conway's law is very closely linked to coupling and cohesion, right? And it's that same thing, people, you put people together that need to work closely together. You basically, the way I describe to people when they talk about, like, how should I divide my teams and so on, and I say, well, when you divide your teams and you put people, you're making a statement. The statement that you're making is that the communication required for these people is extremely high, and so you're gonna structure the organization so that you can create a much higher bandwidth of communication, which is a team. And if it's co-located, it's even higher bandwidth, right? And then if you then have people in a different team, you're making the statement that these people don't need to have the same level of bandwidth for communication with those people, right? So then you have to look at your problem, and when it comes to the problem domain, what is that asking you to do? And this is where XP comes in as well, with the concept of the whole team, right? Pulling the customer out away from the team actually is creating a low cohesion element, right? Is things that want to be together for change to be easier are now sitting apart. And XP tried to bring a whole concept of the whole team, where people who really need to speak to each other all the time, where actually writing, designing, building software, for them people to be together is going to be much easier, because if they are constantly in communication with each other, they will reduce that waste. Again, going back to the lean. So we're kind of going through all these different concepts from the point of view of coupling and cohesion.
Yeah,
And
I will. No, go on.
go on,
Sorry.
go on, go on.
No, I thought you were done.
No, go for it. I was done.
So I wanted to even give like a even more stronger example for like from software to team communication. For example, when we create two components or two modules, I'll put modules, right? So you can calibrate it whichever level. You have two modules. So similar to what you were saying, Mash, like the things that are within the method, the module, they have a high bandwidth of communication and proximity, right? So they interact very closely with each other. But across modules, what you want to have is a very well structured communication. So they have, like in software, we normally create the module interfaces, right? So we create a very precise way for those modules to talk to each other. Normally, you keep that interface as narrow as you can, so that when one module talks to the other, there is a very narrow interface that they go through that interface, but they never go to the internals. Yeah. This way is how we guarantee that those modules are loosely coupled. Quite often, we see in bad systems that, let's say that module 1 has 5 internal pieces, and module 2 has also 5 internal pieces, but they talk directly to each other. There's not a single point of entry to each module. Each one of the 5 pieces of module 1 talks to whichever parts of module 2, right? So this thing, like you you have coupling. You have a huge degree of coupling because the internal parts are all connected, which means that although it seems that there is a separation, but in fact what you have is
one
a
module.
single module.
Now they are apart, so they're making it even more difficult for each other.
Exactly, but because you created a physical separation between them, but the communication across the parts are done at the part level and not at the entry level, you made your problem worse. Yeah. Because like now you have two things that potentially should be together because of the degree of collaboration, and you are making them to be apart, and you create more complexity in doing so. So then either you bring them the two together to be a single module, or you fix those couplings and say, you know what, no parts talking to each part. Just talk through the public interface. And so, if you bring that to the teams, is exactly the same thing. You have one team with 5 people, another team with 5 people. If they just talk to each other as they wish, any person of team 1 talks to any person of team 2 whenever they want, and they keep working like that, maybe keeping those teams separate is the worst thing to do, because now they have different goals, but they collaborate very closely, and that creates friction because you are trying to make them work independently, but they are highly coupled with another team. So what you really wanted to do is that the teams are very cohesive. That means the communication across the individual of the team happens very formally, very often, very quickly. But when they need to go to another team, it needs to be structured. Otherwise, you have that complexity.
Yeah.
Right? So,
and in fact, I was just thinking, the reason you describe a well-defined interface between systems or teams is because once you have a well-defined interface, each side honors that. So they don't need to be in constant communication. They can rely on that being stable. Because what he's trying to do is reduce the communication, because it's a low bandwidth a channel. So you're trying to reduce the communication because it's a low bandwidth. And the way to reduce the communication is to have a common agreement. And this team is going to work based on that same common agreement as this team, right? Knowing that agreement will remain, so they can do whatever as long as they don't break the agreement. And it's exactly the same for systems. So what that means is that low bandwidth communication channels are kept at the low bandwidth, basically.
Looking at other applications and drawing from your example of the BAP, and the fan and so on, fan in and fan out. Like some of those, like for instance, Scrum and defining a product owner as the entry point for the work that the team needs to do. That is trying to solve kind of that problem, and priorities and the connection with the outside world and so on. Another thing that is common as well is related to data. When people are using the same data, and then you have they're either maintaining different copies, and then they need to synchronize and all the things, then trying to have all of these master product X MDM, whatever you want to call it, and trying to try and keep the data together, have some sort of governance. But then again, they're doing a trade-off, right? Then if I need data, fine, as long as it's what this group has decided, right? If I need something else, if I need a different kind of thing, most likely I'm going to have an issue, and because again, I'm not part of that, so I don't have the direct access and so on. And this is where things like the whole data mesh idea is coming from. Like, how do you, instead of going to the extreme and having that centralized thing, how can you split that within the organization and have autonomous groups that are working on different areas of the data, kind of like microservices and so on, right? But taken at the organizational level, and in this case, information or data, support, where they are autonomous enough, they're cohesive enough to be able to do all the things on their own, but they are sharing those components, right? So there's it's a balance between, everyone's having to redo the same thing all over again, to having a centralized storage or point for storing that, versus finding that middle ground, no, where you have autonomy and the benefits, no, of some of the things. But it
It's
is
kind of almost evolution, or because basically what we talk when we talk about interfaces between things, modules, people, different parts of information, those kind of things. What you're talking about is that, in order to enable autonomy, you are standardizing communication between those various parts. But actually, as soon as you standardize, you're putting things in a bit of a stone, so they can't evolve as quickly as they need to evolve. But in order to evolve them quickly, you then need to have higher bandwidth communication. So I think the
But it's not
data mesh
only
idea.
communication. It's not only communication. Decision making as well.
Yeah,
and,
that
and,
I'm
and that
kind of
it's
generalizing
not
it.
only exactly. It's not only the channel or the information flow, but also where decisions are made. Because this is another thing, right? You can have that, but if decisions are made centrally, you still have the same problem,
Well,
right?
this is what I was actually going to talk about, is that, you can either make the decision centrally, but then you kind of almost put one side in power, and you got three-way n ways of communication going on, because what you then have to do is all the parts need to speak to that part, and that one needs to make the decision and then bring the communication back to these parts. And actually, when you talk about community-based standardization processes, where all the parts that do need to talk about to standardize one thing, they all form a committee to actually make that standard happen and evolve that standard. So you are reducing by a one level of this n squared problem. So if you introduce a centralized body of decision making, you're actually, n to the power 3 is much lower than n to the power 4. Right. So what you add is a higher level communication burden if you start having these centralized and in some cases they are needed. But if you can't establish a good way of evolution of certain standards, because in organizations there are other problems as well. There's problems around ownership and all those kind of things. When you have to start worrying about those as well. When you talk about community-based standards bodies and that kind of thing, is that who owns it, who drives the process, who really looks after it, and those kind of things add more complexity. So it's not as simple as that, but there is an element to it.
Yeah, now I might be extrapolating a few things. I was just having a few things in my head, trying to make that comparison from software to organizational aspect in terms of coupling and cohesion. So, for example, imagine you have multiple modules that needs to process different kinds of information. But so the entry point to the system, we have many entry points that you process different parts of information. But at the back, they all share a single module that you do something common for them, right? So at that point, what you are doing, you have the funning kind of problem, right? So all the different inputs will rely on a single backend or service at the back, and the performance of all those channels will be dictated by the performance of this single module. If this module is struggling to cope with the load, it will slow down all the different channels to process stuff. Yeah. So then a common discussion that we have architecturally speaking, of course, like we can resolve that is scaling that module, right? So making that scalable, making stateless, and then having multiple copies and stuff. But then there are also like a question that we talk about sometimes, like, should we duplicate something sometimes? Instead of having a single dependency, we just duplicate that thing at the back. And then we leave all the different modules to be. I'm simplifying this because we can have many different types of solutions for the problem that I'm describing. But those are about coupling and cohesion and duplication also of effort as well. Do you keep things that are common centralized, or you could afford to take things that are common across different modules, duplicate it instead of centralized?
Yeah.
So if you go to the organizational side, take the QA department or a production services department. It's the same thing. So multiple teams, let's say they have a dependence on the QA team. So while the QA team don't QA their piece of work, they cannot go live. But if the QA team is swamped by requests by multiple teams, they will need to synchronize all the releases, right? So then you can, one option is like we do in software, we optimize the QA team. We make the QA team scale, right? Another option is we duplicate the QA effort across the different teams.
And
so
then you optimize the development teams. Yeah.
Then we optimize the development teams. Exactly. So then you create a separation from the development team. So then you also have a trade-off here. What are you optimizing for? Do you want to keep each one of the streams, each one of your modules, or each one of your teams independent? But then you will have some duplication, sort of, right? So I'm just talking in general terms.
Yeah. Your QA, all your QAs are not 100% utilized.
Right. Exactly. So or you just like try to create, because when you duplicate that, you optimize your teams as you would optimize your modules. However, different teams or different modules will have their specific needs. They will be or more active or less active. They will have the workload might be bigger or slower. So for example, the amount of QA, then what you end up doing when you duplicate, you local optimize, right? So you might optimize that common module that is now duplicated to fit better that module that is in there. So now it's duplicated, but not quite. It's not the same. The same with QA. Some QAs start becoming differently. So then you need to decide, do I want to keep my QA consistent? Or would I afford to local optimize for the modules? So balancing that is also an interesting thing, because we have that problem in software the same way that you would have in the organization. Yeah. You need to rely potentially in communities of practices or general guidelines and stuff.
Or the Spotify model.
Right. Then it's solved. As soon as you put like some tribes in there,
exactly. And then you do like this, and everything is solved.
Exactly. Okay? Put some tribes. There we go. Yeah. So,
but I think it's like fascinating, and you can bring that all back to the same kind of coupling and cohesion concept. Where do you want to be coupled? And having centralized things increases coupling, right? But at a different level. And you were talking about these different levels in the organization as well. Where do you want to be cohesive and where you don't want to be cohesive? Do you want a cohesive QA team, but then it's coupled with all the dev teams? Or do you want independent dev teams and less cohesive QA? Yeah. So the same thing applies. Yeah. I think this is a good point for us to let's try to finish this in less than 60 minutes this time. But I don't know. Is there anything major we want to? I don't know, Jose. You are very good at these kind of things, introducing a question that will.
At the end, this is my moment. No?
It's your moment.
No. I think we cover a lot of things. Again, it would be good if people want to, because we also discussed the Conway law and the impact in structure and in software and vice versa. No, so that will be another good episode to watch, I guess. No, just other areas that we could go into in other episodes, like things. There are certain governance kind of models like sociocracy and so on that try to get that balance to some extent, and they recognize that there may be different entry points for requests to your system and so on, and there's a bunch of patterns that can be used. Which, if we look at them, I'm going to do that. But if we look at them, probably there might be a lot of similarities with solutions that we use in software to deal with similar ideas. No, but no. Other than that, we can finish.
Okay, so Mash, final words from you then.
I think in fact, the last thing that you talked about, right? Doesn't matter how, as soon as we talk about dependencies, right? I think this is the main thing. It doesn't matter if it's at even the 2 or 3 different lines of code, all the way to teams, organizations, systems, coupling and cohesion are a very important aspect to consider. It's actually very closely, well, first of all, it's very close. It is in a way systems thinking, but it's actually, to me, I see that as quite a universal concept. I don't want to call it a principle or anything, but it is a very universal. It's a tool to help you simplify. It's closely related to the whole idea. We try to divide and conquer at many places because we have really complex systems and we divide them in order to simplify. But as soon as we divide, the idea of coupling and cohesion comes straight bang in there, and you have to think about that. And understanding it well will actually make you a better developer, would make you a better team, would make you a better architect, would make you a better product owner, a manager. All these things, you really need to understand this particular concept.
It's all about managing that communication, right? So how do you want that communication to flow across all the different parts? How we're going to organize those parts to achieve optimal communication. So yeah, so anything else, Jose? Maybe no, you're good? Okay. So you're not going to ask another question, right? Okay. So, okay, cool.
I saw you already shut it down by the way you asked the question. You don't have any more questions?
Yeah, you don't have a question, Jose, right?
It's like, you're not going to take that donut, right? You're going to take that donut, right? The last donut.
Okay, well, thanks, everyone. If you stayed with us until now. So always remember, if you like those chats, subscribe to the channel, leave your comments, any topic that you'd like us to discuss, let us know. And I hope you enjoyed this episode, and I see you next time. See you later.
Thank you. Bye-bye.
Bye-bye.